Introduction to Java.
For computer programming, there are several high-level languages, and the programmer can use a suitable programming language for writing the program. In this chapter, you will learn about the programming language Java, which is available free of cost, and moreover, it is a very powerful programming language. Just look around you. You will find various things like book, pen, pencil, cell phone, cycle, bike, car, etc. All these are objects. The world we live in is full of objects, and the list of objects is countless. Objects are our subject of concentration for programming. Languages like Java revolve around the objects. What is an object? In the real world, an object is a thing that is visible and can be touched. Any entity which has some characteristics. Something which can perform some work. If we study various things around us, meeting the above criteria, we can say that all things have unique identity, definite state or characteristics, behavior. For example, we can say that a lemon is an object. It has its unique identity and can be recognized by its shape. Its characteristics are: it is spherical in shape. Its color is yellow. Its behavior is citrus in nature. It always tastes sour. There are numerous objects around us, including us, that possess unique identity, characteristics, and behavior. If you compare the software object with a real-world object, they have very similar characteristics. Software objects also have a state and behavior. A software object's state is stored in fields and behavior is shown via methods. So in software development, methods operate on the internal state of an object, and the object-to-object communication is done via methods. Data abstraction. Abstraction in Java is used to hide certain details and only show the essential features of the object. In other words, it deals with the outside view of an object, interface. For example, for sending an SMS from your mobile, what do you have to do? You just type the text and send the message. You do not know the internal processing about the message delivery of the mobile phone. Abstraction lets you focus on what the object does instead of how it does it. It refers to the act of representing only essential features without including the background details or any explanations. Encapsulation. Encapsulation means combination of characteristics and behavior in a combined single unit. For example, a capsule which can have mixture of several medicines. Encapsulation is the way in which both data and the functions reside that work on a data under a single unit. Encapsulation is a process of binding data members and member functions into a single unit. Encapsulation is a fundamental concept of object-oriented programming. Wrapping up of data and functions into a single unit called class is known as encapsulation. Real-world example of encapsulation. A TV set is encapsulated with a cover, and we can operate with a remote, and there's no need to open the TV and change the channel. Here, everything is in private except remote, so that anyone can access, not to operate and change the things in TV. Now the question arises, can you directly access the data from the encapsulated thing? The answer is no. The only way to access the data is provided by the functions. The data cannot be accessed directly. If you want to read the data from an encapsulated object, you have to call a member function in the object. The data is hidden from the outside world. Hiding the data from the external world keeps the object safe. No accidental alteration can take place. How to create an object. To create an object, the new operator is used with the name of class you want to create. The parentheses in the example are empty because they can be empty also. Keeping the parentheses empty is the most simple and basic case when a basic object is created. Parentheses can have arguments that determine the initial values of instance variable. What is a class? A class is a collection of objects. A class may be defined as a group of objects with the same attributes and operations. The class is a keyword in Java programming. The user deals with class instead of dealing with various individual objects. The objects belonging to a class are called instances of the class. In OOP, a programmer deals with classes and not with the individual objects. In this example, the color class contains various colors like red, blue, green, etc. The colors are distinct, but they belong to the color class. Every object created from the same class will have similar features. When you create a Java program, you have to design and construct a set of classes. After the compilation, when the program is run, the various objects are called from these classes in case of need and used according to the instructions given in the program. In a class, attributes are defined by variables. These variables are the storage locations in the memory where information is stored. If we bundled a bunch of attributes and let this bunch behave according to the operations, that can be done. We have an object. The current values of the attributes define the state of the object, and the operations define the behavior. Operations are often referred to as member functions, methods, or messages, Writing and understanding Java program. /* simplest of the Java programs */ Line number 1. / by Malhotra. Line number 2. Class simple program curly brace open. Line number 3. Public static void main brackets open string args bracket open close bracket close curly brace open. Line number 4. System.out.println brackets open inverted commas begin wish you happy learning inverted commas close windows close semicolon. Line number 5. Curly braces closed. Line number 6. Curly braces closed. Line number 7. Description of the program. Line number 1 / simplest of the Java programs * The description written within the * and * is called comment. The comments are used for explaining the program. The comments are not executed by Java. Line number 2 / by Malhotra. The description written after / is also a comment. There is no need to close the comment line by /. Line number 3. Class simple program curly braces open. This line declares a class which is an object-oriented construct. Everything is placed inside a class. The word class is a keyword. Simple program is a name which is called identifier, which specifies the name of class to be defined. The program always starts with the opening brace, curly brace open. Line number 4. Public static void main brackets open string args bracket open close bracket close curly brace open. This line defines a method named main. A Java program which includes this main bracket open bracket closed method, string args bracket open bracket closed declares a parameter named args, which has an array of objects of the class type string. We can also write it as string bracket open bracket closed args. The above main method is followed by another opening brace. Line number 5. System.out.println brackets open inverted commas begin wish you happy learning inverted commas closed brackets closed semicolon. In the above program, this is the only executable statement. The println method is a member of out object, which is a static data member of system class. The string to be printed is kept in double quotes. The statement ends with a semicolon. All Java statements end with a semicolon. The statement will give the output, wish you happy learning. Line number 6. Closing brace. This is a closing brace to close the statement. Line number 7. Closed brace. Every Java program must end with a closing brace. The line number 4 in the above program can be written as public void main brackets open bracket closed. The line number 5 can also be written as system.out.print bracket open inverted commas wish you happy learning inverted commas closed bracket closed semicolon. Here we have used print instead of println. Use of println brackets open bracket closed sends the next output to the next line, whereas print bracket open bracket closed sends on the same line. Variable. As the name suggests, a variable is a quantity which varies during a program execution. A variable is the name of location where the information is stored. This location exists in the computer memory where the value or information can be stored, and in case of need, it can be retrieved. Depending upon the size of variable, it can occupy one or more memory address. Variables can be created by any combination of letters without spaces. Variable names may be short or descriptive, but a descriptive variable name makes it easier to understand the flow of the program. Some keywords are reserved in Java and cannot be used as variable names like if, while, main, for, etc. This can be done by the following syntax. Syntax: type variable name, semicolon. You can think of an identifier as variable's name. For example, int m, semicolon, m is equal to 15, semicolon. In this example, m is an identifier that refers to the variable with the same name. Int m, brackets open, bracket close, curly brace open, curly brace closed, m, brackets open, brackets closed, semicolon. M would still be an identifier, but it would identify a function. Just as Rama can identify both a person and some kind of non-profit organization. Declaration of variables. Declaration of variable is essential before using it in a Java program. If declaration is not done, error message will appear while compiling the program. Variable may have built-in data type or user-defined data type. A variable name is an identifier, and all rules pertaining to identifiers apply to the variables. Syntax: data type, variable name, semicolon. Following are some examples of declaration of variables. It is clear from the examples, when two or more identifiers belong to the same data type, we can use single declaration statement. Identifiers are separated by commas. The main advantage of declaration of variables is not at compulsion to trace back the beginning of the program to ascertain the data type linked with these identifiers. A variable can be declared anywhere in the Java program. How to assign a value to a variable. The value to a variable can be assigned using equal to sign. This equal sign is called assignment operator. In Java programs, we have to assign initial values to the variables frequently. For example, int x equal 5, semicolon. Double y equal to 10.0, semicolon. Char letter is equal to, within commas, a, semicolon. In case the user or programmer does not initialize any value to the variable, Java compiler automatically assigns default value depending upon its data type. The following chart summarizes the default values for different data types. How to initialize variables. To initialize and to create a name identifier for the variable, declare its data type and assign an initial value to it. You can initialize a variable in two different ways. The first way uses a declaration statement to declare the data type and an assignment statement to assign a value to the variable. The second way uses a single initialization statement. How to initialize a variable in two statements. Syntax, type variable name, semicolon. Variable name equal value, semicolon. Example, int counter, semicolon. Declaration statement. Counter is equal to 1, semicolon. Assignment statement. How to initialize a variable in one statement. Syntax, type variable name is equal to value, semicolon. Examples, int counter is equal to 1, semicolon. Initialization statement. Int x is equal to 0, comma, y is equal to 0, semicolon. Initialize two variables in one statement. Double price is equal to 14.95, semicolon. Float interest rate is equal to 8.125 f, semicolon. F indicates a float type. Long number of bytes 2000 L. L indicates a long type. Char letter is equal a within commas, semicolon. Stored as a 2-byte Unicode character. Boolean valid is equal false, semicolon, where false is a keyword. Declaring multiple variables. You can declare multiple variables within Java programs. You have to tell the variable name and its type to the Java compiler. Look at these statements. Int length, semicolon. Int breadth, semicolon. Int height, semicolon. These variables are of the same type, int. When the variables are of same type, you can declare them in a single line. The above three statements can also be declared as int length, breadth, height, semicolon. Each variable name is separated by comma. Operators. An operator is a symbol or letter which causes the compiler to take an action and yield a value. An operator acts on different data items, entities called operands. For example, x plus y is an expression in which sign plus is an operator which specifies the operation of addition. Let us discuss the different types of operators. Arithmetical operators. Arithmetical operators are used for various mathematical calculations. The result of an arithmetical expression is a numerical value. An arithmetical expression may be a variable or a constant or a combination of both. These variables or functions are connected with arithmetical operators. Arithmetical operators are of following types. 1. Unary arithmetic operator. 2. Binary arithmetic operator. Unary arithmetic operator. The unary operator needs only one operand. It may be plus or minus. For example, minus a, plus b use unary operator, negative and positive. Unary positive. The unary plus operator makes an expression positive. For example, if x is equal plus 10 semicolon, then the value of x is positive. These are equivalent values in this case. X is equal to 10. X is equal plus 10. Plus x is equal 10. Unary negative. The unary negative operator makes an expression negative. For example, if x equals minus 10 semicolon, then the value of x is negative. These are equivalent values in this case. X is equal to minus 10 minus x equals 10. Binary arithmetic operator. The binary arithmetic operators act upon two operands. The following arithmetic operators require two operands. Symbol, meaning, example. Addition or plus. A plus b. Subtraction or minus. A minus b. Multiplication. A multiplied b. Slash or division. A slash b. Modulus or remainder. A modulus b. Addition operator. Addition operator plus adds two values of operands. For example, a plus b. If a equals 20 and b equals 5, then a plus b equals 25. The result, 25, is sum of the values of two operands. Subtraction operator. Subtraction operator minus subtracts two values of operands. Second value from first. For example, a minus b. If a is equal to 21 and b equals 9, then a minus b equals 12. Multiplication operator. Multiplication operator multiplies the values of operands. For example, a multiplied b. If a is equal to 9 and b is equal 7, then a multiplied b equals 63. Division operator. division operator divides the first operand by the second. For example, A divided by B. If A is equal 85 and B equals 5, then A divided by B equals 17. Modulus operator. Modulus operator finds the remainder when first operand is divided by the second. For example, A modulus B. If A is equal to 37 and B equals 5, then A modulus B equals 2, because on dividing 37 by 5, we get 2 as remainder. Increment and decrement operators. Java provides increment and decrement operators, which are not provided by many other languages. These operators are called increment and decrement operators. The increment operator adds 1 to its operand. Increment x means x is equal to x plus 1. X increment means x is equal to x plus 1. And decrement x means x is equal x minus 1. X decrement means x is equal to x minus 1. These operators exist in two types: prefix and postfix. Prefix. Prefix means before its operand. It should be noted that prefix increment or decrement operator like increment I and decrement I follow the rule first change and then use. They first change the value of this operand and then use a new value in the expression. For example, take the following expressions. I equals increment I multiplied 8, where I equals 8 initially. The result will be 72 for this program segment. A equals B multiplied decrement A, where A equals 5 and B equals 6 initially. The result will be 24 for this program segment. Postfix. Postfix means after its operand. It should be noted that postfix increment or decrement operators like I increment and I decrement follow the rule first use and then change. They first use the same value and then increment or decrement the value and use it in the expression. For example, I equals I increment multiplied 9, where I equals 9 initially. The result will be 81 for this program segment. It should be carefully noted that increment and decrement operators operate on a single operand. Postfix operators have high precedence over prefix operators. A increment has high precedence over increment A. A decrement has high precedence over decrement A. When the increment and decrement operators are used in expressions instead of single operand, they produce different results. Illustration. Evaluate A is equal to B increment plus B, where B equals 10. Solution. Note that increment B is prefix unary operator. it will have higher precedence over B. The rule is first change and then use. Increment B will be 10 plus 1 equals 11. Now incremented value will be used in the expression. A is equal to 10 plus 11 equals 21. Relational operators. Relational operators are used to determine the relationship between different operands. These are used in the work of comparison also. The two mathematical expressions can be compared by a relational operator. The relational expression returns 0 if the relation is false and returns 1 if the relation is true. The 6 relational operators are shown in the following table. The following table will help you in understanding the relational operators and their results. Here, value of A plus B along with their relationship has been shown. Please note, 0 means false, 1 means true. Thus, A greater than B, which is true, represented by 1. Relational expressions are used in decision-making statements like if and while. Example, if x equals 2 and y equals 5, calculate the following expressions. If x not equal to y, x less than y, x plus y less than equal to y. Solution. The expression is true because x is equal to 2 and y equals 5. These values are not equal, hence we get the result 1 true. Second, the expression is true because the value of x is less than that of y. Result is 1 true. The expression is false because the value of x plus y equals 2 plus 5 equals 7 is greater than the value of y. Hence, the result is 0, false. Logical operators. Logical operators combine the results of 2 or more than 2 expressions. The mode of connecting relationship in these expressions refers as logic, and the resulting expressions are called logical expressions. The logical expression returns 1 if the result is true, and it returns 0 if the result is false. Java provides 3 logical operators which are listed as follows. Symbol, meaning, logical negation, not, logical or, logical and. Logical negation. The logical operator has logical negation. It, however, has higher precedence than the remaining logical operators. This operator is also called logical not operator. This works on single operand and can be referred to as unary operator. To negate an expression, the expression should be enclosed in parentheses. The logical negation not operator negates the real value of the expression. If the expression is true, logical negation not expression becomes false, and if the expression is false, logical negation not expression becomes true. If the expression is 0, not expression is 1. And if the expression is non-zero, not expression is 0. Example: not 10 within brackets is a non-zero expression, but it results into 0, false. Not 10 greater than 8 within brackets is a true expression because 10 is greater than 8, but it results into 0, false. The logical OR operator. The logical OR operator combines two expressions. If both the operands are false, the logical OR operation is false. The logical OR expressions results into 1, true, if either of the operands is true. Given that int a equals 1, comma b equals 2, comma I equals 5, semicolon, then evaluate a plus b greater than 2 or I not equal to 2. Solution: a plus b greater than 2, it is true, and I not equal to 2, it is also true. Therefore, a plus b greater than 2 or I not equal to 2 is true. The logical AND operator. The logical AND operator connects two expressions to make them as a single expression. If both original expressions are true, the resulting expression results in value 1, true, otherwise false. Examples: 15 equals 3 and 8 equals 8. It results into 0, false, because the first expression is false. 5 equals 5 and 8 equals 8. It results into 1, true, because both the expressions are true. 5 greater than 9 and 6 greater than 2, it results into 0, false, because the first expression is false. Programming constructs. In a program, statements may be executed sequentially, selectively, and repetitively. All programming languages provide program constructs. They are used to control the order, flow in which statements are executed or not executed. Let us study 3 different types of programming constructs. Sequence. A sequence is a control structure in which a set of instructions are written. Each instruction is executed once in the order in which they are written. In a sequence structure, each command is executed and then checked, so the next command can be executed. The next command in the sequence has been predetermined by the programmer. Selection. Selection is a basic logic structure. With selection, a question is asked, and depending on the answer, one or more courses of action are taken, and then the program will move to the next event, and the statement will be executed. A selection can also be known as an if-then-else. Selection construct is also called decision construct because it helps in decision making. Iteration, repetitive. Iteration is a control structure in which a group of statements is executed repeatedly. The computer iterates through the loop to allow each command to be executed over and over. It is also called a loop or repetition. Branching. In a sequential form of execution of statements, the program flows simply and unconditional without making any decision. Many times it is required to alter the flow of the sequence of instructions. Java language provides statements that can change the flow of a sequence of instructions. These statements are called control statements. These statements help to jump from one part of the program to another. The control transfer may be conditional or unconditional. Selection statements. Sometimes the program is to be executed depending upon a particular condition. If the statement is used for this selective execution, conditional statements, a conditional statement executes a code segment based on a condition, such as an equality test, A equal B, a comparison test, A greater than B, or a Boolean test. The branching which is based on a particular condition is called conditional branching. These statements are also called decision-making statements. If statement. The if statement helps in selecting one alternative out of the two. The execution of if statement starts with the evaluation of condition. General form of if statement. If expression statement. An expression can appear in the parentheses of the if statement. If the expression has 0 value, it is considered as false. If the value is non-zero, this is true. Java provides the following constructs for implementing the selection control structure. If construct, if-else construct, if-else-if construct, if-if-else construct, switch construct. If-else statement. Instead of using two if statements, you can use an if-else statement instead. The execution of the if-else statement starts with the evaluation of the condition. The method of testing one condition and then the other works, but it is a complex one. The keyword else provides readable code. If expression. Statement 1, semicolon, else, statement, semicolon. When the computer executes an if statement, it evaluates the expression. If the value is true, the computer executes the first statement and skips the statement that follows the else. If the value of the expression is false, then the computer skips the first statement and executes the second one. Note that, in any case, one and only one of the two statements inside the if statement is executed. Two statements represent alternative courses of action. The computer decides between these courses of action based on the value of the expression. If-else-if statement. For more than two choices, the if-else-if statement can be used. First, the condition 1 is tested, and if it is true, then statement 1 is executed, and all other if-else-if construct ends. If condition 1 is false, then the statement 1 is ignored and condition 2 is tested. If it is true, then statement 2 is executed, and remaining if-else-if construct is terminated. And if the condition 2 is false, statement 2 is ignored and condition 3 is tested. This process continues in this way. Repetitive statements. Repetitive iteration statements cause statements to be executed 0 or more times, subject to some loop termination criteria. When these statements are compound statements, they are executed in order except when either the break statement or the continue statement is encountered. Java provides 3 iteration statements: while, do, and for. Each of these iterates until its termination expression evaluates to 0, false, or until loop termination is forced with a break statement. Java provides the following loop constructs for iterations: while loop, do-while loop, for loop, while loop. The while loop construct is used for repetitive execution of a program, subject to conditions which may have 0, false, or non-zero, true value. General syntax: while, within brackets, condition statement. While is a keyword in Java. Condition is an expression, and the statement can be a simple or compound one. Illustration: demonstration of while loop to print a given number in reverse order. Class, while loop, curly brace open. Public void, while loop, within brackets, int value, curly brace open. System.out.println, brackets open, within double inverted commas, entered number is, plus value, brackets closed, semicolon. System.out.print, brackets open, within double inverted commas, number in reverse order is, brackets closed, semicolon. intr underscore digit, semicolon. If, within brackets, value less than equal to 0, brackets closed, return, semicolon. While, bracket open, value not equal to 0, bracket closed, curly brace open, r underscore digit equal value modulus 10, semicolon. System.out.print, bracket open, r underscore digit, bracket closed, semicolon. Value equals value divided by 10, semicolon. Curly brace closed, curly brace closed, curly brace closed. Output of the program. Entered number is 987654321. Number in reverse order is 1, 2, 3, 4, 5, 6, 7, 8, 9. Do-while loop. Like a while loop, the do-while loop is another repetitive control structure. In while loop, the condition is tested before execution, whereas in a do-while loop, the condition is tested after execution. The do-while loop is an exit-controlled loop in Java. General syntax: do, curly brace open, statement, semicolon, curly brace closed, while, condition within brackets, semicolon. Condition may be a single or compound statement. The condition may have 0 or non-zero. A semicolon is placed at the end of the while statement. While, within brackets condition, semicolon. Distinction between do-while and while loops. Do-while. 1. The loop executes the statement at least once. 2. The condition is tested after execution. If the condition is false, the computer keeps executing the loop. While. Number 1. The while loop will not execute even once if the condition is false. 2. The condition is tested before execution. 3. The loop terminates if the condition becomes false. 2 types of loops. A pre-test loop is a loop in which the loop condition is tested before execution of the body. For example, a while loop. The for loop is also a pre-test loop. Pre-test loop is also known by the other names, entry-controlled or top-tested loops. A post-test loop is a loop in which the loop condition is tested after execution of the body. For example, a do-while loop. Post-test loop is also known by the other names, exit-controlled or bottom-tested loops. The for loop. The for loop is also used for a repetitive execution of a code, but for a fixed number of times. The program knows well in advance how many times the loop is to be executed. General syntax. For, within brackets, initial expression, semicolon, test expression, semicolon, update expression, bracket closed, curly brace open, statement, semicolon, curly brace closed. This loop is executed at initial value, middle value, and final value. Execution of a for loop. 1. In first step, the initial expression is evaluated. 2. In the next step, the test expression is evaluated. If the value is non-zero, the loop is terminated without execution. 3. After the execution of for loop, the update expression is evaluated. Programming example. Write a program to create a mathematical table. Solution. Class math table, curly brace open. Public void main, within brackets, curly brace open. int I, j, k, semicolon. For, within bracket, I equals 0, semicolon, I less than equal to 15, semicolon, I increment, bracket closed, curly brace open. K equals I multiplied by j, semicolon. System.out.println, within bracket, plus I, plus within double inverted commas, multiply, plus j, plus within inverted commas, equals, plus k, bracket closed, semicolon. Curly brace closed, curly brace closed, curly brace closed, curly brace closed.